Hello guys, welcome back to my new video. In today's video, I'll solve make binary tree from linked list. Go to problem statement. In problem statement, you have given a linked list, and your task is to construct a binary tree and print the label order traversal of the binary tree. Go to whiteboard. First, you have to understand what is binary tree. Basically, binary tree is a tree which represent three components: root node, left node, and right node, and their children. Okay, root node means like binary tree like this. Suppose this is 4. Okay, 4, and binary tree like this represent here like this. This is root node, and this is child node. Okay, this is child node. I will also define you what is child node, what is root node, and like this. Okay, this is a binary tree, and this is root node. This first node always called root node. This starting node. Okay, and under of this root node, these are the children of this root node. Means these are the parent node you can say, and these are the children of this parent node. Okay, and this is called left node, and this is called right node. Okay, binary like this. Now you have to just find out from a binary tree from the linked list. Now go to example to more understand. This is our example given. Okay, and this is our linked list. This is in input. Okay, and first, what is our task? Our task is first construct a binary tree. We just basically construct to follow the linked list node. First node, root node here, which one is come first? One, because one is the first node. Okay, so root node is one, and next is 2. 2 will come here, this left side will make binary root left right like this, root left right. Okay, next node is 3. 3 will come here, root, and next node is 4. 4 will come this side left, and last node is 5. 5 will come here, 5. Okay, and now we have to traverse this binary tree. How can we traverse? We traverse this binary tree follow as root left right like this order. Write down root left right. Follow this path. We have to traverse. We have to traverse the binary tree. Okay. Now root node is 1. Write down 1, and next root left node is 2. So write down 2, and root left right node is 3. Write down 3, and then forward. Is there any node under 3? No. So go move to forward, and this node 2 have two children, 4 and 5. So left node is 4. We always start from left node, 4 left node, and right node is 5. 5 5. This is our binary, and this is the level of binary. Okay, in problem statement we have just given this output here. This is our output. Okay. Now in next example, this is a linked list. Now construct binary tree. A binary tree will be like this. Root node is 5, and then left node 4, and right node 3, and then this 2 will come over here, 2 and 1 right side, 1. Okay, now traverse the binary tree. We will traverse root left right, root left right as this order. Okay, now root node is 5, and right node is 4. Write down 4, and then left right node is, left is 4, right is 3. Left is 4, right is 3. Now there are any nodes in node these 3? No, there are not any node. So move forward. You can see in node 4 it have two children, means it have two node, 2 and 1. Okay, now we have to traverse this path. Now left is 2 and right is 1. Now this is our path. Okay, in output it will show this. Now what is the time complexity and space complexity? Time complexity and space complexity both are O of n, big of n. This. Now go to code. In code, first we define a tree node structure. I will zoom it for your define structure, and then we construct a create a new node, self data. Okay, so it will cover self left node and self right node. Then we create a function to convert binarity. It will convert binarity from linked list. This is our problem statement to construct binarity from linked list. So we'll define this function to convert binarity. Then we create root node of the binary, and then we just pop the current node from the queue. Then we go to linked list, and left we traverse our binary tree from left to right, root left right. Okay, then we move to next node. After that, then we take to next node from the linked list, and then we move to next node, and at the last we return root. Then we create a linked list to a binary tree. Okay, then we'll push it, and then like this we perform the level order traversal. This one we have to print the level order traversal, so we create this for level order traversal, and at the last it will return print laser level order. Okay, and it will last one is to create linked list to node. This one construct a new node. Now compile and run, and now submit. If you want binary tree explanation how what is binary tree and types, comment us. Based on your comments I will upload video very soon about binary tree. Okay, today's problem was solved. See you next video. Till then, tada, bye bye.